The next part of factoring is learning how to factor out a greatest common factor. If you remember a greatest common factor, let's just review what a GCF is. And I'm sure you've heard of this before. Let's just remind ourselves what this is. A greatest common factor is when you have multiple numbers and you find the largest number that all of them can be divided by. For example, if I have 12, 18, and let's say 30. What can all of those numbers be divided by, or the largest number that all those can be divided by? Well, the factors of 12 are 1 and 12, 2 and 6, 3 and 4. Factors of 18 are 1 and 18, 2 and 9, 3 and 6. Factors of 30 are 1 and 30, 2 and 15, 3 and 10, 5 and 6. So what's in all three of those? That's the largest in all three of those. Well, it's 6. The greatest common factor is 6. Okay, and that's what we're going to look for in A, B, and C in our quadratic before we factor. And I'll show you what I mean here in a second. So before factoring, look at that A, B, and C. Is there a common factor? Well, if it were 12, 18, and 30, 6 would be the common factor. Factor out the greatest common factor by dividing each term by that factor, in this case 6, and then put the greatest common factor in front and simplify the terms. And it's not difficult at all. So let's look at this. A, B, and C are 2, 6, and 8. 2, 6, and 8, if you can write them out, you don't have to. If you know exactly what it is, that's fine. But 1 and 2, and this is 1 and 6, 2 and 3, this is 1 and 8, and 2 and 4. Well, what's common in all of those? 2. So I'm going to divide each term by 2, just like my steps told me. Then I'm going to put that 2 in front, and I'm going to simplify. 2 divided by 2 is 1, so that's just 1x squared. 6 divided by 2 is 3, so it's 3x. 8 divided by 2 is 4. And if you think about it, that was just the distributive property backwards. If I were to distribute this 2 back into that quadratic, I would get this thing. I'm just doing the distributive property backwards, and that's the goal. Now, once we're done, we can keep factoring the inside here. It's very similar to what we did with the negative in our first video. What are 2 factors of 1 and 4, 1 times 4, 2 factors of 4 that add up to 3? And this is a little box I use sometimes instead of writing out that whole sentence. Well, they are 2 and 2. Well, factors of 4 are 1 and 4 and 2 and 2. Do we have any? 2 plus 2 is 4. 4 plus 1 is 5. And I can't make one negative because it has to multiply to a positive. So this we would call as prime. This is unfactorable. This is as far as we can go because there is nothing that works that multiplies to 4 and adds to 3. So we are done. On Math Excel, the question I'll ask, is it prime? If it's prime, that means it looks like this. You can't factor it, or there is no, it's unfactorable, all kinds of things. All right, the next one, greatest common factor, 5, 10, and 75. Well, the greatest common factor for this one is going to be 5. So I'm going to divide by 5, divide by 5, divide by 5, put the 5 out in front, and then simplify. 5 divided by 5 is 1, so I have x squared plus 2x, because 10 divided by 5 is 2, minus 75 divided by 5 is 15. Now I'm going to try to factor the rest. We'll try it and see if it works. 1 times negative 15 is negative 15. That has to add to 2. What are the 2 factors of negative 15 that add to 2? Well, we have factors of 15 are 1 and 15 and 3 and 5. Well, if I make 3 negative and 5 positive, that'll work. Negative 3 plus 5 is positive 2. Negative 3 times 5 is negative 15. So there it is. I keep that 5 in front, and I have x minus 3 and x plus 5. So negative 3 and 5. All right, let's try another one. Greatest common factor for this one, well, since this is 3, is this divisible by 3? Yes. Is this divisible by 3? Yes. So I'm going to put a 3 out in front. And then I have x squared minus, not 21. What's 21 divided by 3? 7. So 7x minus 30 divided by 3, 90 divided by 3 is 30. Now I'm going to try to factor inside of the parentheses if possible. 1 times negative 30 is negative 30. That adds up to negative 7, so factors of 30, we have 1 and 30, 2 and 15, 3 and 10, 5 and 6. See if I can squish that in there. 5 and 6. Do any of those multiply to negative 30 and add to negative 7? Yes. 3 and 10. Negative 10 plus 3 is negative 7. Negative 10 times 3 is negative 30. So I have x plus 3 and x minus 10. So that would be 3 and negative 10. Finally, oh, we just did that. No, we didn't. Okay, another one. 3, 9, and 30. Greatest common factor here. Be careful. What do you see in all of these that's different? An x is common. So we're going to say the greatest common factor is going to be 3x. This is not a quadratic. This is a cube because there's an x cube in the beginning. So greatest common factor is going to be 3x, and I'm going to divide this by 3x, divide this by 3x, divide this by 3x. You have to be careful there. So this is going to give me x squared because the 3's cancel, and I cancel one of the x's, plus 3x minus 10. Now I can go ahead and FOIL from there, or factor from there. I have 1 times negative 10 is negative 10. That adds up to 3. Factors of 10, 1 and 10, 2 and 5. So I need something that multiplies to 10 and adds to 3. Well, positive 5 and negative 2. 5 minus 2 is 3. 5 times negative 2 is negative 10. So they're negative 2 and 5. So I have x minus 2 and x plus